Electricity powers our world, it lights our homes, runs our appliances, and connects us globally. But have you ever stopped to wonder where this electricity comes from and how it reaches us? The answer lies in a complex and interconnected system known as the electrical grid. Imagine a vast network of power plants, transmission lines, and substations working together to deliver electricity from its source to your fingertips. The electrical grid is the backbone of modern society, essential for our daily lives, powering everything from our smartphones to our hospitals. Without a reliable electrical grid, our world would come to a standstill. Understanding how the grid works is crucial for appreciating its significance and addressing the challenges it faces in a world with increasing energy demands. To understand it better, we can break it down into three main components: generation, transmission, and distribution. The journey of electricity begins at power plants. These plants are like giant factories that produce electricity using various energy sources. Some power plants burn fossil fuels like coal, oil, and natural gas to generate electricity. Others harness the power of renewable sources like wind, solar, hydro, and nuclear energy. Once electricity is generated at power plants, it needs to be transported over long distances to reach homes and businesses. This is where the transmission system comes in. Transmission lines, those tall towers carrying high voltage power lines, act like highways for electricity, transporting it efficiently across states and even countries. Before electricity can be used in our homes, its voltage needs to be lowered to a safe and usable level. Substations play a crucial role, acting as step-down transformers, reducing the high voltage from transmission lines to lower voltages suitable for distribution. The distribution network is the final leg of the electricity journey, bringing electricity from substations to our neighborhoods and ultimately to our homes and businesses. Power generation is the first step in the electrical grid's journey. This involves converting energy sources into electricity. Fossil fuels like coal have been primary for years. Renewable sources offer a cleaner alternative. Solar power converts sunlight directly into electricity. Wind turbines capture wind energy. Hydroelectric power uses water flow. The future lies in a diverse mix of energy sources. Section 4, High Voltage Highways, Electricity's Long Journey. Once generated at power plants, electricity travels long distances to our homes and businesses. The transmission system, a network of high-voltage power lines, makes this journey possible. These lines, often towering over landscapes, carry electricity at incredibly high voltages. High voltage minimizes energy loss during transport. This ensures efficient transmission with minimal waste. The system's interconnected lines provide redundancy and flexibility. Section 5, the last mile, delivering power to you. As electricity travels the high-voltage highways of the transmission system, it eventually reaches its final destination, our homes and businesses. But before we can power our devices, the electricity must undergo one final transformation. This is where the distribution network comes into play, ensuring that electricity arrives at our doorstep at a safe and usable voltage. Substations play a crucial role in this voltage transformation, taking the high-voltage electricity from the transmission system and reducing it to lower voltages suitable for distribution. The distribution network is a complex system designed to handle varying electricity demands throughout the day. Section 6. The grid's impact more than just lights on. The electrical grid is more than just a network of wires and substations. It's the invisible backbone of modern society, underpinning our daily lives in countless ways. From the moment we wake up to the time we go to sleep, we rely on the grid for essential services, communication, healthcare, transportation, and entertainment. Without a reliable electrical grid, our world as we know it would grind to a halt. Imagine a day without electricity. Our homes would be dark, our appliances useless, and our communication systems down. Hospitals would struggle to function, businesses would close, and transportation would be severely disrupted. The economic impact of a widespread power outage would be catastrophic, highlighting our dependence on a stable and reliable electrical grid. The electrical grid plays a critical role in economic growth and development, providing the power necessary for businesses to operate, industries to thrive, and economies to flourish. Section 7. The future is Smart Grid 2.0 and beyond. The electrical grid, as we know it, is on the cusp of a transformative evolution. Faced with increasing energy demands, the integration of renewable energy sources and the need for greater efficiency and reliability, the grid of the future will be smarter, more flexible and more resilient than ever before. One of the most significant developments in the evolution of the electrical grid is the emergence of smart grid technologies. Smart grids leverage digital technologies, sensors and data analytics to optimize grid operations, improve efficiency and enhance reliability. By monitoring grid conditions in real time and using predictive analytics, smart grids can anticipate and respond to changes in demand, prevent outages, and integrate renewable energy sources more effectively. Energy storage is another crucial component of the future grid, ensuring a constant and reliable electricity supply. The transition to a smarter, more sustainable electrical grid requires significant investment in infrastructure upgrades, research and development, and policy changes.